Welcome to the deep dive. We take a stack of sources, break them down, and pull out the knowledge you need to stay informed and maybe even surprised.
Yeah, hopefully surprised in a good way.
Definitely. So today we're diving into one of the most, well, I think, exciting areas in AI right now. Intelligent agents.
Mm-hmm.
These aren't just, static systems that answer questions. They're capable of acting, of solving problems in the real world by interacting with external systems and data.
Right. Think about the shift there. For a long time, AI has been about pattern recognition or generating text based on just one prompt.
Yeah, a single shot.
Exactly. Agents move us towards systems that can, understand a goal, figure out a plan, execute steps, and even adapt based on the results they see. They have agency.
Agency. That's the key word. And our mission in this deep dive is to understand how you can build these powerful agentic systems, specifically using Google Cloud.
Okay.
We've looked through your sources, which cover, everything from core development kits and starter templates to the underlying platform services that make it all tick.
Sounds comprehensive.
Yeah, so we're going to unpack the essential building blocks Google Cloud offers for creating these agents, see how they connect, and hopefully give you a clear path to start your own agent development journey.
All right, let's set the stage then. When we talk about agentic systems on Google Cloud, what are we really talking about? What's the fundamental layer?
Well, at the heart of it all, you've got the large language models, the LLMs.
The brains.
Exactly. Google's multimodal Gemini models on Vertex AI, they're the intelligence engine. They understand natural language, they reason, generate text, code, all that good stuff. But like we said, an agent is more than just an LLM.
Definitely more. Agents are designed to go beyond that single prompt response cycle. They use the LLM's reasoning capabilities to, plan and execute a series of steps or actions.
Okay.
And a key pattern we see described in the sources for how these agents interact with the outside world is the REACT pattern.
REACT. I've seen that. That's thought, action, observation, right?
That's the one.
I find it such an intuitive way to think about it. The agent have a goal.
Mm-hmm.
The LLM has a thought about what needs doing next. Based on that thought, it decides on an action could be anything, right? Searching a database, calling an API, running some code.
Precisely. Then it gets an observation back from that action. The search results, the API response, whatever the tool returns.
Okay, and that observation is key.
Absolutely critical. It's fed back into the LLM's context, influencing its next thought. So you get this loop thought, action, observation, repeat until the agent figures out it has enough info or, the task is complete.
Right.
And this iterative process is really how agents can tackle complex problems that need multiple steps and interactions with the world.
And it also helps make them more reliable, doesn't it? Because they're grounding their thinking in real-world observations from these tools. Less chance of just making stuff up.
Absolutely. That ability to use external tools to fetch real information or perform concrete tasks, that's what connects the agent to the world. It lets it verify or augment the LLM's internal knowledge. Yeah.
Without tools, an agent is basically just an LLM doing multi-step reasoning in its own head. With tools, it can interact, learn from that interaction, and adapt its plan.
Okay, so we've got the intelligent LLM brain, patterns like REACT for thinking and planning, and this crucial ability to use tools to interact. Now, let's look at how Google Cloud gives you the specific components to actually build these.
Right, the building block.
Exactly. Your sources point to three main pieces: the Agent Development Kit, or ADK, the Agent Starter Pack, and then the platform layer, which we see referred to using a few names. Actually, AI applications, Agent Space, Agent Builder, Agent Engine, quite a few.
Yeah, it can seem like a lot of names, but they fit together. Yeah. Think of the ADK as the foundational framework for building the agent's core logic itself.
Okay, the coding part.
Kind of, yeah. Then the starter pack is there to jumpstart your development with pre-built, production-ready examples. Helps you get going faster.
Like templates. It's exactly like templates. And the platform layer, AI applications, Agent Space, Agent Engine, that's where you deploy, manage, connect your agent to data, and enable it to take those actions we talked about.
Got it. Let's start with the Agent Development Kit, the ADK.
Yeah.
If I'm a developer building an agent, why would I reach for this kit specifically?
Well, the ADK gives you a structured way to define how your agent behaves. I mean, you could try to build an agent just by prompting an LLM and writing a ton of custom code around it.
Which sounds complex.
It can be, yeah. The ADK offers abstractions and components that handle a lot of that common complexity. It gives you a framework for plugging in the LLM, defining your tools, managing the agent's state through that React loop, handling the interactions. It basically provides structure.
Okay, so it simplifies orchestrating the whole workflow, the thinking, the acting, the observing.
Exactly. It helps manage that flow. And a really key part of that is how it handles integrating tools, which the ADK does very flexibly.
Right. You mentioned tools are crucial. What kinds of tools does the ADK support based on the sources?
It seems pretty versatile. It supports pre-built tools from Google Cloud itself, things like Google Search, code execution, tools for retrieval augmented generation, or RG.
We'll definitely come back to Orish.
Oh, yeah. But beyond that, and this is important, it lets you integrate third-party tools pretty easily. So if you're already using popular agent frameworks, say LangChain or Crew AI, the ADK has ways to bring in tools built with those.
Oh, that's good. So you're not locked into only Google's stuff.
Precisely. That bring your own idea extends to tools. And critically, the ADK lets you create your own custom tools.
Tailored ones.
Yeah, for your specific business needs. If you have some internal API or maybe a legacy system the agent needs to talk to, you can wrap that functionality up as a custom tool for your ADK agent to use. The sources even mention building agents as tools.
Whoa, agents calling other agents as tools.
Yeah.
That really opens things up, doesn't it? Like building a team of specialist agents that collaborate.
It does point towards that potential for complex modular systems. And speaking of modularity and control, the ADK also has this concept called callbacks.
Callbacks. What are those for at agent development?
They're actually super useful for getting visibility into what your agent is doing and even influencing it. The ADK provides these hooks into different stages of the agent's life cycle.
Hooks, like interception points.
Sort of. You can use things like before agent callback and after agent callback to run code just before or after the main agent loop. But even more granularly, there are before model callback and after model callback.
Okay, before and after talking to the LLM itself.
Exactly. Triggered right before and after the call to the underlying language model.
So why would I, as a developer, want to use those specific model callbacks? What's the benefit?
They give you really fine-grained control and observability. For instance, with before model callback, you could dynamically tweak the prompt going to the LLM based on the agent's current situation, or maybe just log the exact prompt for debugging.
Ah, for tracking analysis.
Right. And after model callback lets you look at the raw response from the LLM before the agent processes it further. You could log it, or potentially even intercept and modify it if needed. It's pretty essential for serious debugging, monitoring, and evaluating how well your agent's performing.
That kind of visibility sounds critical if you're putting this into production.
Absolutely.
You mentioned multi-agent systems earlier, too. How does the ADK support putting agents together like that?
Well, the ADK seems designed with this kind of composition in mind. The sources give a really neat example using something called a sequential agent named Hill Monitor.
Okay.
Now, this isn't just one agent, it's actually composed of sub-agents. It uses a critic agent. Its job is to fact-check or evaluate some text. Then, depending on what the critic finds, it passes the text to a reviser agent, which is responsible for fixing any inaccuracies.
Like an editor workflow.
Kind of, yeah. It shows how you can build these specialized agents and then chain them together using the ADK to handle more sophisticated multi-stage tasks.
That's a very clear picture of how agents could collaborate.
Okay.
Okay, so the ADK gives us structure, tools, callbacks, multi-agent support. But building an agent from scratch, even with a kit, still sounds like it could be significant effort.
It definitely can be.
Is that where the Agent Starter Pack fits in? To speed things up?
Absolutely. The Agent Starter Pack is designed specifically for that to accelerate your path to getting a working agent up and running. It's basically a collection of production-ready templates for common agent patterns.
Okay.
And the core idea here, as mentioned before, is bring your own agent, offering flexibility.
Bring your own agent. What does that mean in practice here?
It means the starter pack isn't only giving you templates built strictly with the ADK, Google's kit.
Oh.
While there is an ACK-based template, which gives you a solid starting point for a general conversational React agent using the ADK, they recognize that the agent world is diverse. Lots of tools out there.
Right.
So the starter pack includes templates built using other popular frameworks, too.
Like you mentioned LangGraph or Crew AI earlier.
Exactly. You'll find templates like LangGraph Base React that gives you a React agent built with LangGraph, which is known to be good for building stateful multi-step agentic workflows.
Okay.
And there's also a A coding crew template. This one shows how you could build a multi-agent system specifically for collaborative coding tasks, but using the Crew AI framework.
Interesting. So depending on maybe what framework I already know or what my specific needs are, I can find a relevant starting point in the pack.
That's the idea. And the templates cover different use cases as well. There's Agentic AI for building a sophisticated document Q&A agent that's grounded in your own data.
The RAD pattern again?
Mm-hmm. Or Live in Hubby for a real-time multimodal RA agent. The key takeaway here is that Google seems to be acknowledging the diverse landscape of agent frameworks out there.
Yeah.
And they're providing production templates that integrate these popular tools, giving you choice and flexibility instead of forcing you down just one path.
And using these templates helps overcome some common hurdles you hit when building agents.
Yes, definitely. These templates are designed with production deployment in mind. They try to help address complexities around, deployment itself, evaluation, customization, and building in the necessary observability right from the start. These are often pretty big challenges when you're building agents for real-world use.
All right, that makes sense. So we've built our agent logic, maybe using the ADK, possibly starting from a starter pack template. Now we need to actually deploy this thing, connect it to our data, and let it do stuff.
Right, make it live.
Exactly. This brings us to that platform layer. We heard those names: AI applications, agent space, agent engine, agent builder. Can you clarify how these pieces fit together? It got a little confusing.
Yeah, it can seem that way with multiple names floating around for related concepts. Let's try to break it down based on the sources. Think of AI applications as the big umbrella. It's the overarching suite or capability on Google Cloud for building and deploying intelligent applications, including agents.
Okay, the whole suite.
Right. Now, within this suite, you have interfaces and runtimes specifically for agents. Agent space, which is sometimes called agent builder, seems to be more the console or the interface where you design and manage your agents. This is especially true if you're taking a no-code or low-code approach.
To UI, maybe?
Possibly, yeah. Agent Engine, on the other hand, sounds like the specific managed runtime environment within AI applications. It's where the agents are actually deployed and executed.
Okay, let me see if I got that. AI applications, the big suite. Agent Space Builder, the Design Management Console. Agent Engine is the runtime where the agent code actually runs.
That seems like a helpful way to distinguish them based on the descriptions. And this platform layer provides critical services that your agents absolutely need. Two of the most important ones highlighted are data stores and actions.
Okay, let's tackle data stores first.
Yeah.
This sounds crucial for ag retrieval, augmented generation, which we keep mentioning.
Absolutely crucial. The platform provides these built-in managed connectors to a whole bunch of enterprise data sources.
Like what kind of sources?
Well, unstructured documents in cloud storage, structured data in BigQuery, website content, Google Drive, even Gmail and calendar data, potentially healthcare data, or custom vector embeddings if you have those.
Wow, quite a range.
It is. And the real power isn't just connecting to the data, it's how the platform integrates security and access controls from those sources right into the RRAC process.
Ah, so it respects existing permissions.
Seems to be the goal. So the agent running on this platform can securely access and retrieve information from these connected sources to inform its responses.
So the platform handles the retrieval part.
Yes, that's the core idea of RAG on this platform. When the agent needs info, it leverages these data stores. The platform handles fetching the relevant snippets and provides them to the LLM. This lets the LLM generate a response that's grounded in your specific data.
Which drastically reduces the chance of hallucination, right? Making stuff up.
Exactly. The insight here is that providing the secure, managed access to diverse enterprise data out of the box really simplifies building agents that you can trust more because they're grounded in fact.
Okay, data stores let the agent know things. What about actions? How does the platform let the agent do things?
That's where actions come in. This capability lets your agents interact with external services or systems. So when the agent's reasoning figures out it needs to perform a task beyond just generating text, like, say, sending an email, creating a calendar event, looking something up in an old system.
Like a practical task.
Right. It invokes an action that's been defined on the platform.
Is this related to function calling, that concept we hear about with LLMs?
Yes, very much so. It's essentially Google Cloud's way of implementing function calling within this agent framework. The LLM might decide, okay, I need to call this specific function or tool.
Right.
On this platform, those tools are exposed as actions. The platform manages that whole mechanism. The LLM outputs a structured call to an action, and the platform executes it. You can define these actions using open API schemas if you have custom APIs, or use pre-built integrations for things like Google Workspace apps.
So the platform handles actually making the external call to the agent.
Correct. It manages the execution of those interactions. So putting it together, the platform gives the agent both its knowledge base through data stores for RAG and its ability to interact with the world through actions for function calling.
Knowledge and power, essentially.
You could say that. And the platform offers flexibility in how you actually create the agent that uses these. We mentioned you can use the agent space agent builder interface, maybe for no-code agent design. But you can also register agents you've built externally using frameworks like the ADK we discussed.
And how does that work? How does my ADK agent get onto this platform, specifically onto the agent engine runtime?
The sources describe a specific step. You wrap your ADK agent using a particular construct, reasoningengines.addcap.
No, ADGAP.
Yeah. This step basically packages up your ADK agent's logic and configuration into a format that Agent Engine understands and can run. Once it's wrapped, you deploy it, likely through the AI applications or agent space interface, onto the Agent Engine.
Okay, let me trace that flow. I build the agent logic with ADK, maybe starting with a starter pack template.
Yeah.
I define how it uses tools, which might internally use data stores for RAG or trigger actions for function calling on the platform.
Right.
Then I wrap my agent code with this ADCAP thing, and then I deploy that package to Agent Engine within the AI application suite. And once it's there, it gains access to all those platform capabilities like the data stores and actions.
Exactly. That seems to be the intended path for bringing these custom ADK agents onto the managed platform. Agent Engine provides that scalable managed environment for your wrapped ADK agents to run, interact with data, trigger actions, and potentially even be orchestrated as part of larger workflows, maybe even alongside agents built using the no-code tools.
That really clarifies how the pieces fit together. You've got the kit for building the core logic, the pack for a head start, and then the platform for grounding it in data and giving it hands to act in the world.
It really looks like a comprehensive ecosystem they're building, trying to support that full life cycle of agent development from coding all the way to production deployment and management.
Now, given all these options we've discussed, the ADK itself, the starter pack with templates for ADK, but also LangGraph, Crew AI, plus the platform's own no-code builder, it does feel like there are quite a few paths a developer could take.
Yeah, choice is good, but it can also be overwhelming.
Exactly. Where does someone even start, according to the sources? How do you navigate this?
That's a very fair question, and the sources seem to acknowledge this. They point back quite strongly to the Agent Starter Pack as a key resource, not just for the templates themselves, but almost as a guide.
How so?
Well, because it provides these concrete production-ready examples using different frameworks and patterns, ADK, LangGraph, Crew AI, you can actually look at these implementations side by side. You can see which pattern or framework might resonate most with your specific problem, or maybe your team's existing technical skills, and pick that as your starting point.
So you explore the pack to find the best fit.
Exactly. It embodies that bring your own agent idea by giving you practical working options to choose from. It serves as both an accelerator and a kind of exploration tool for different architectural patterns.
Okay.
And of course, for those just getting started with LLMs in general, the sources also mention Vertex AI Studio as a foundational tool.
Right, for basic model interaction.
Yeah, it's a great place to just test the models, experiment with different prompting techniques, and really understand the core capabilities of the LLMs before you even start building the more complex agentic logic around them.
It sounds like Google Cloud is trying to provide a whole spectrum of tools then. From low-level building blocks for developers who want maximum control like the ADK, to accelerators for common patterns with Starter Pack, and then this managed platform AI applications, Agent Space, Agent Engine, providing those essential services like data integration and action execution.
That definitely seems to be the strategy playing out. Giving developers the tools and the platform services they need to build these increasingly sophisticated applications that are not just conversational, but truly intelligent, capable of reasoning, accessing information securely, and taking real actions in the world.
And that brings us towards the end of this deep dive. We've navigated through the landscape of building AI agents on Google Cloud. We looked at the core agent development kit, the ADK, for building the agent's logic and integrating tools.
Right, the foundation.
Then the agent starter pack for accelerating development with those production-ready templates across different frameworks.
Getting you started quickly.
And finally, that crucial platform layer, AI applications, agent space, and agent engine, which provides the data stores for grounding agents with REA and the actions for enabling them to interact with external systems.
Yeah, understanding how these components work together really empowers you, the listener, to move beyond simple chatbots. You can start building intelligent applications that truly understand context, reason through problems, securely leverage your own enterprise data, and perform actual real-world tasks. It unlocks a lot of potential for automation and creating much more dynamic user experiences.
It really does. And as we wrap up, it leaves us with maybe a final provocative thought for you to consider. As these agentic systems become more and more capable accessing vast amounts of information, taking autonomous actions on our behalf, how do we make sure we build and deploy them responsibly?
That's the big question.
How do we ensure they're not only effective and powerful, but also fundamentally transparent, interpretable, and aligned with our values, especially as they start tackling increasingly complex and potentially impactful tasks?